That yellow line means something. That's the 3. Okay? One of these has an endpoint, one of these doesn't. Okay, so if I were to graph this, I have a y-intercept of 10, and it goes down 2, down 2, right 1, down 2, right 1. So basically, this function, if I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if I squeeze it, 10, down 2, right 1, down 2, right 1, down 2, right 1. So I have an open dot here, and it looks like that. The other equation is a parabola. So this parabola, negative b over 2a, so I got negative 1 over 2, so at half comma something. That's 1/4 plus half. So that's half 3/4. Okay, so negative half up 3/4 is here. All right, there's our piecewise function. It's not as pretty can be. Sorry about that. So, my friends, as I am traveling this way, if I plugged 3 in here, 10 minus 2 times 3, so this is going to give me 4 on the top. And then if I come back on this one this way, I plug 4 in here, I get 16. That is going to give me 12. Okay. Does this limit exist being, if I went one way or the other, I got 2 different numbers? Okay? I don't have a positive or negative here, so it has to get to the same exact number from both sides. One way got us to 4, one way got us to 12. Does the limit exist? No. Does not exist. Okay? Clear as mud? All right. Can I go to number 6?
I tried, but I couldn't figure it out.
It will. I'll show you how to do it. All right. So this particular function, we want this to go to 2. What happens if I plug 2 into the bottom? 0. So it's undefined if I directly plug it in. Okay? So there's got to be a different way that we can approach this. So let's take a look at what the graph looks like, see if it tells us anything different. Come on, baby. Y equals fraction x squared plus 6x plus 9 over x minus 2. All right, so as x equals 2, what does it look like as x goes to 2? I'm coming from both directions. Coming from both directions to get to that blue line. So one of them goes where and one of them goes where? Anyone participating? Yeah, so one goes to positive infinity, one goes to negative infinity. Does the limit exist if I went to 2 different locations?
No.
No. Okay. All right, problem number 7. Problem number 7 says they give us the limit as x goes to 100 of r at x. And they say the total revenue for a product is given by that equation where x is the number of units. Okay, so if I replace this with 1600x minus x squared, I could directly plug that in here and here. So that's going to give me that, two more zeros, so 160,000 minus 100,000. So the limit here is 60,000 is the revenue. I just could directly plug it in to get the limit because I didn't have any denominators or any square roots or things like that. Problem number 8, during an 8-hour shift, the rate of change of productivity in units per hour and total widgets assembled. Yay, we're back to the widgets. After T hours, the job is given by that, and they have it bound by 0 to 8 hours. Okay, so find the limit as x approaches 4. Find the limit as x approaches 8 from the left.
But since it ends at
So we're coming from the left, so it should be an end point. Okay, so number 8. So we have r at t is equal to 128 t squared plus 6t over t squared plus 6t, can't read it, plus 18 squared. All right, so we want to know, find the limit at 4. So first thing you want to check, can I just plug it in and see what happens? So I'm going to get 128, 16 plus 24. And then I'm going to get 16 plus 24 plus 18 quantity squared. Yowzers. I'm just going to use Desmos as my calculator. Getting rid of this and this. So fraction, fraction. 128, 16 plus 24. And then I got 16 plus 24 plus 18 quantity squared. So looks like it comes out to a nice 1.52. That is our rate of change productivity. We're getting 1.52 whatever widgets over a certain amount of hours. And then if I wanted to know what 8 coming from the negative side would be, so what I'm going to do is I'm going to change these. So 8 squared is 64. 20, that's 48. 64 plus 24, wait, plus 48 plus 18. So that gives us, so our production of widgets drops towards the end of the day. Oh, we need to start getting more coffee breaks or something. Is the rate of productivity higher near lunch break or quitting time? It's by lunch break, it's higher. Okay. And then for problems 9 through 11, use analytical methods to evaluate the limits. You can verify your conclusions by graphing the functions. Okay, so let's graph y equals 3 divided by x plus 1. So x plus 1, as I go to infinity, if I go forever to the right, where does that purple line look like it's getting really close to? So if I plug numbers in and my fraction becomes a smaller and smaller and smaller fraction, smallest fraction gets to 0. Okay. So the second problem x to the third minus 1. X to the third plus 4. X raised to the third plus 4. All right. As I go to the right forever, a little bump in there. So what horizontal line does it look like we are getting really close to? If I go y equals 1. Yeah, we're getting to 1. Basically, how you kind of look at that is if you plugged infinity to the top, you plugged infinity to the bottom. Infinity minus 1 and infinity plus 4 is basically 1 over 1. So that'll take place just nicely there. And then as I go to negative infinity at the other one, two x raised to the third on bottom minus 1 or minus 2. And on top, 5x to the third minus 4x. Oh, what a unique looking graph. So I think, so we're going to go to the left forever. And I like the bumps in there. So I think y equals 5 divided by 2. Yep, that's it. So basically what we could do on number 11 is you look at the, being the exponent on top and the exponent on bottom are the same. You take the lead coefficients, so 5 over 2 becomes like the end behavior, and that becomes our limit. So 5/2 is our answer. Now, friends, those of you who are here, who didn't get the homework done now? Someone's like, oh crap, Sturb's checking now. Well, hello. Starbucks gift card here. That dude's here. Appreciate you guys. Is Ethan Bernard here?
Yeah.
Okay. Max here. Diego's here. Quinn, you here? No Quinn. Chavez got here. Daddy Otis, you got it done now.
You.
I knew you would. I'm giving you a hard time. Dwyer, you got yours done now. Sammy Johnson, yours done now? All right. Last year's done. Mobs, you got yours done now? Emily?
Yeah.
Abby, is yours now done? Pierce, yours done now?
Yeah.
Rodriguez, yours done now?
Yeah.
You guys are the best. Ben, yours is now done? Story's still not here. Gabe, yours done now?
Yeah.
You're the best. You're a strip, I know. Ashley Thomas, yours done now?
Yes.
And Hank, yours is done now, correct? Okay, I feel better about myself. All right. What do you guys want to do today? Today's Tuesday, isn't it? All right. Direct. What do I want to do? Ooh. All right. My friends, I wanted to give you the opportunity to see how you do. Let's take, so this says limits. Warm up is on the sheet. Give you a few minutes to get a start on that, and then I'll go over the first few. Cool? I think you should be able to hang with me. All right. This negative here means I'm coming from the left to -1. So I'm traveling along this line here. Where does this dotted line, this black dotted line, appear that it's going to in the y direction? Negative infinity is correct. If that's supposed to be a positive. If I'm approaching 1 from the positive side, where is this green dotted line going? Positive infinity. And then the limit as I approach 1 from the positive side, from the right, so I'm coming up this. What does it appear this point as here in the y direction? -1. Purple-ish. All right, if I come to -1 from the negative side, where am I getting to as I follow this dotted line? 0. So what can you tell me about the limit as I approach 1, being that this and this are two different answers? Does not exist. Good, DNE. All right. Orange. All right, orange. As x approaches 3, so I get to 1, 2, 3. What is this value basically right here? I go with -3. And last color, purple. As I go to negative infinity, where does this appear to be going in the y direction?
0.
0 is correct, the x-axis. And last one, as I go to the right this way, where does this line appear to be going in the y direction? Hey, we are doing limits, my friends. Welcome to the world of calculus. Is that all they do? No, they do more. All right. So if you look down at number 2, a few things that you want to take into consideration. So sometimes a derivative's not going to, or not a derivative, a limit's not going to stand out unless you factor things. So if I factor at the top, it's going to break down to this, which then that breaks down to and then the bottom is going to break down to x minus 3 and x plus 1. So what you should do on this is you have to realize these cancel each other out. That should allow you to start doing the limits a little bit easier when you have this, because a lot of times you can directly plug in. So in order for you to solve A, as the limit approaches 3 from the positive side, just plug 3 directly in. So that's going to give me 4 over 4, so this is just 1. Okay? I can directly plug it in a lot of times.
But because it's 3, wouldn't it? I was coming from the positive. So
It doesn't matter. So I could directly just plug the 3 itself in. It doesn't really matter which side because it didn't make an undefined term. If I had left my x minus 3's in there, because basically you're now just doing the limit based on this. You're not worried about that hole. Okay? Oh, dude. Best day ever. Didn't let me down. A key to my heart. Okay. This one's going to work the same way. And then this one really works. The reason it works, even though we have a hole, we're getting to the same exact location of where that hole is going to exist. All right, but now we're going to get ourselves in some trouble. Just because Stirrup wants to get into trouble. Not sure how we're going to get in trouble, but hey. Okay, if I approach -1 from the positive, if I directly plug -1 in, this becomes 0. Okay, so we have to think about another way to get there. So there's got to be another way that we can get there. Okay, so I'd say if we did jump back onto Desmos and just graph the original or the green function, it should work. Y equals, forgot what it was, 2 and then x minus 1. Over x plus 1. All right. So that's what our graph basically looks like. If we are getting to -1, so think about this. As I am coming from, following my arrow, starting here, I'm coming this way. This is jumping straight up to positive infinity. So by looking at this, if I get to this value, -1, excuse me, -1. If I get to that, as I come from the left to the green line, and I come from the right to the green line, what can you tell me about the limit? Yeah, so from the positive, if I come from the positive, I go to -infinity. If I come from the negative, I go to positive infinity. If I just want the limit at -1, it goes to 2 different locations, so it does not exist. All right, my friends, I gave you some opportunity. Now, do you guys want a lot of homework tonight, or does it matter?
I don't want a lot of homework.
All right, I'll tell you what. Let's have you work on limits 4.2. One through 9. I will check that off tomorrow. I might not be quite as lenient tomorrow on, oh, Stir, if you do it for me, I'll copy it down and I'll take credit for it. Cool?
Cool.
Deal?
Yeah.
Giddy up.